Hello, and welcome to the AI Research Roundup. I'm your host, Alex, and here we explore the latest in AI research. Alright, today we're looking at a paper titled MASt3R-SLAM Real Time Dense SLAM with 3D Reconstruction Priors, published December 16, 2024. So, this paper introduces a real-time system for dense SLAM using just a single camera, building on a powerful 3D reconstruction prior called MASt3R for robust results on real-world videos. Okay, and speaking of exploring the work further, this image actually shows the official GitHub repository for MASt3R-SLAM. As you can see, it looks pretty comprehensive, offering installation guides, scripts for downloading standard datasets, and clear instructions for running examples, or even a live demo with a camera. So, it seems quite accessible if you want to try it yourself. Alright, so this figure here gives us a nice visual example of MASt3R-SLAM in action. On the left, you see the basic MASt3R prior working, taking two views of a statue and generating a 3D point map. Then, on the right, we see the full SLAM system's output on the burger sequence, showing a dense reconstruction of the scene and the camera poses, all done in real time. Okay, so building on that, this figure here actually lays out the whole system diagram for MASt3R-SLAM. We saw the MASt3R part before, but this shows how it fits into the full pipeline, followed by efficient point map matching, then tracking the camera pose and fusing the point maps, and finally handling loop closures and global optimization for a consistent map. Okay, building on the system diagram we just saw, this figure provides another result. But this time, it's an outdoor scene facing extreme zoom changes between consecutive keyframes, shown on the left. On the right, you see the resulting dense reconstruction and camera poses, showing how the system handles this uncalibrated scenario robustly. Going a bit further, this figure shifts focus to compare the actual 3D reconstruction quality. It shows MASt3R-SLAM, labeled hours, side by side with Droid SLAM on the 7 scenes dataset. You see the ground truth points in red versus the estimated blue points. And importantly, the chamfer distance metrics show MASt3R-SLAM producing more consistent geometry here. Okay, and continuing that theme of reconstruction quality, this figure shifts to the EuroC dataset. It visually compares the 3D reconstructions from Droid SLAM, Span3R, and MASt3R-SLAM, labeled Rs again. Well, you can really see the qualitative difference. MASt3R-SLAM's reconstruction looks noticeably more complete and solid compared to the others here. So yeah, as we saw across those examples, MASt3R-SLAM really delivers on creating detailed, dense 3D maps in real time, even in challenging conditions like those zoom changes. The key, I think, is how it effectively uses those learned 3D priors to get much better geometry compared to prior methods. This kind of progress is really important, pushing towards more capable robotic navigation and richer augmented reality. Well, that wraps up our look at MASt3R-SLAM. Thanks for tuning in to the